Here we have some problems that have to do with the distance formula. And this kind of complicated looking formula is a way to measure the distance between 2 points on a coordinate plane. So if you got some point here and you got some point here, the distance between them is this straight line. And we can figure out the length of that by using an application of what's actually the Pythagorean theorem. Remember, the Pythagorean theorem applies to right triangles, and it says that if you square one of the shorter sides and add it to the square of the other shorter side, that would equal the hypotenuse squared. So if you know a couple of sides in a right triangle, you can always figure out the length of the third one. Well, in this situation where we have 2 points and we draw a diagonal between them, we can find out how far apart they are just on the x. So subtracting the x coordinates from each other. That would give us this distance right here. And do the same thing for the y. That would give us this distance right here. If we join those lines, we get a right triangle when you put all three of those lines together. And this formula here really is, here's your a squared, right? Here's your b squared. Those are those two sides. And this d is really the hypotenuse of the triangle, or your c. And they've solved this for the hypotenuse by taking the square root of one of those sides. It's as if we had done this, take the square root of both sides. That just becomes c, or in the distance formula we call it d, a little confusingly. But it's really the same formula. Anyway, you don't even need to know that to apply this. All you have to do is know what goes in each of these spots. D is usually what we're solving for, so that just often stays D. The x2, x1, y2, y1, well, the first point would be your x1 and your y1 for the x and y coordinates of that point. And the second point would be your x2 and your y2. Now all we have to do is plug these numbers in here and crunch it out, and we should get our answer. So let's see if we can set that up. We've got our D equals, and then I'm going to make a big, long radical symbol here. So the first bit is x2 minus x1. So we take the x coordinate from the second point, that's 0. We subtract the x coordinate from the first point, that's the square root of 5. And then that quantity gets squared. Then we add that to same thing for the y values. So y2 is negative square root of 10. And we subtract y1, which is 0. And then we square that. All right, let's see if we can simplify what's inside the parentheses here. 0 minus the square root of 5 is just the negative square root of 5. And that's going to get squared. And then negative square root of 10 minus 0 is just negative square root of 10. And that's going to get squared. So these negative signs are going to go away when we square these things. And if you come up with a negative value for distance, you've done something wrong, because distance is always a positive value. A negative distance doesn't really make sense in this context. And then when we square something that's a square root, it's like the square root just goes away. So this becomes a positive 5. That's the negative square root of 5 squared is a positive 5. Likewise, this one is a positive 10. So we add those together, we get 15, but remember, all this is under that big radical sign. So our distance equals the square root of 15, and in this case, we don't have to plug that into a calculator to get a decimal approximation. It's just one of our answers here. So that's sort of the basic kind of problem. There are some twists and turns we get in these problems. Let's try this next one, and I'm going to sketch the distance formula up here again. And remember, it's x2 minus x1 squared plus y2 minus y1. Make that look more like a 2 squared. Okay, so let's take our values again. This is x1 and y1, and x2 and y2. And let's start plugging them in. So distance equals big radical symbol. So x2 in this case is negative 4, and minus x1 is minus a negative 2. Make sure you get all the signs in there. Don't drop any of those. That'll definitely throw you off if you do. And here y2 is 3, and y1 is 5. So that's 3 minus 5 quantity squared. Okay, so let's simplify what's in the parentheses here. -4 minus a -2. Well, minus a negative is like plus, so -4 plus 2, that's going to be a -2. And then we'll have to square that. And 3 minus 5, well, that's also a -2. And we'll have to square that. When you square a -2, you get a +4. So this is 4 plus 4, or 8. But remember, all that's under the square root sign. So distance equals square root of 8. And we're done, right? Well, none of these answer choices say the square root of 8. So what's the problem here? Don't be tempted to choose 8. 8 and the square root of 8 are definitely not the same number. If you plug the square root of 8 into your calculator, actually, let's do that. Let me grab the calculator here. So if you plug in 8 and take the square root, you can see it's 2.82. It's nowhere near 8. So which answer choice is this? Well, it's not -10. Remember, distance is never going to be negative. It's not 10, because we saw it was 2 point something. It's not 8. So it's got to be this one, right? Well, you can test it. You can say 2 and then take the square root of that. So that's this part right here. And then multiply that by 2. And boom, you've got it. So if you're in a situation where you came up with the square root of some other number, and up in your answer choices are square roots of some other numbers multiplied by something, take out your calculator and test and see if they're the same thing. You could also just factor this, and this is probably what math teachers would want you to do. They'd want you to say, well, I know that 8 is 2 times 4, and I can rewrite the square root of 2 times 4 as the square root of 2 times the square root of 4, and I know that the square root of 4 equals 2, so really this is the square root of 2 times 2, and I can just rearrange the way I write that, so 2 times the square root of 2. So there it is, and that's our answer up here. But sometimes these numbers can be tricky, and if the factoring looks like it'll take a long time to do, just grab your calculator and try these out. All right, let me show you one more type of problem. This one's pretty tricky. I'm going to put my distance formula up here again. What you'll notice about this one is they're actually giving us the distance. They're telling us it's the square root of 41. These 2 points are square root of 41 units apart. But then you'll see in the coordinates, our x2 is actually the letter k. So what are they doing here? Well, they want us to solve for that letter k. They want to know what point it is that would be square root of 41 units apart from this point. So that adds a little bit more trick to it. And let me show you sort of the traditional math teacher way to do this. It involves, well, we're going to plug in k here instead of the number. We're going to have to square it. We're going to get a quadratic equation, and we'll have to factor it. A lot of steps. But let me show you how that works. First, I'm going to take this and plug it in for d, because they're telling us that's the distance here, square root of 41. And then, big radical sign. So x2 minus x1. Well, x2 is k, and x1 is 1. So this is k minus 1, and that's got to be squared. And then on our y, we have -3 for y2, and -7, so minus a -7 for y1. Okay, now we need to simplify what's in these parentheses. Let me take the y-coordinate first, because that's probably the easiest. -3 minus a -7, that's actually going to be like +7, so that's a +4. So this is 4 squared. What's this, though? K minus 1 squared. Well, something squared is itself times itself. So we could write down k minus 1 times k minus 1, and we could FOIL that out. Take the first terms, you get k squared. Take the outside terms, k times minus 1, that's a minus k. Take the inside terms, minus 1 times k, that's another minus k. Take the last terms, -1 times -1 is a +1. And this simplifies out to, let's write it over here, k squared minus 2k plus 1. So we have k squared minus 2k plus 1 plus 4 squared. Well, 4 squared is 16, so this is k squared minus 2k plus 17. And remember, all of this is under the big radical sign. And over on this side, we have 41 under the radical sign. At this point, everything is under a radical sign on both sides of the equation. I am allowed to get rid of those by just squaring. So we're going to square this side, and we're going to square this side. All that does is remove the radical signs. So we get 41 equals k squared minus 2k plus 17. Now, this is a quadratic equation. It's got this squared, this k squared term. It may have been a while since you solved one of these, but what we typically like to do is set the thing equal to 0 so that we can factor it. So I'm going to subtract 41 from both sides. And what does that make? A negative 24, I think. So we'll get k squared minus 2k minus 24. And that all equals 0. Now, when we have a quadratic set equal to 0, we can factor it, if it's one that's easy to factor anyway. And the way we do that, we take this first squared term and we just split it up between the two factors. K times k is going to be k squared. So that's fine. And then we need numbers after it that are going to multiply out to negative 24 and add up to negative 2. So the numbers I'm looking for are factors of 24. Well, actually factors of negative 24. I know, therefore, one of them is going to be positive and one of them is going to be negative because that's the only combination you can have to multiply out to a negative number. And then let's see, we want a difference in the factors of 2. So 6 and 4 pop to mind because they're 2 apart. So if I made the 6 negative and the 4 positive, a negative 6 and a positive 4 would add up to negative 2. They would multiply out to negative 4. So those are my factors. If you want to test that, you just FOIL this out. You should get this thing up here again. And then what you do next is you set each of these factors equal to 0 and then solve them to get the values for k. So k plus 4 equals 0. I would just subtract 4 from each side, and I would get k equals negative 4. And k minus 6 equals 0. I would add 6 to both sides, and I'd get k equals a positive 6. And lucky for us, that is one of the answer choices. So we must not have made any mistakes along the way. So that's great. So this is sort of the traditional way to solve a problem like this. You might find it easier, depending on whether you like to solve quadratic equations better or whether you like to crunch multiple calculations better. But you could just take these values in the answer choices and start systematically plugging them in for k. So start with a 6. See if that works. Does this part of the equation come out to the square root of 41? If it doesn't, then that answer's out. And you could work through all the choices just plugging in the values for k. Or if you think you can work with a quadratic equation, you can try it this way. So that is some work with the distance formula.